Hello, welcome to the day 3 of our machine learning project. For those of you who are in class, welcome, and those watching on YouTube, welcome. In today's topic, we're going to focus on feature engineering for power data. So this is going to provide a comprehensive guide to analyzing household power consumption. All right, so let's look at the overview. Now, this lecture introduces a practical guide to feature engineering using a household power consumption dataset. We will explore how to transform raw data into meaningful input for machine learning models using time series and statistical features. Now, let's really talk about what feature engineering is, a bit of the introduction. This presentation explored the importance and techniques of feature engineering tailored for household power data, providing insights on maximizing predictive performance through effective data manipulation. Let's understand important libraries in today's lecture. Now, what are data libraries? Let's understand what libraries are. Now, data libraries like Pandas allows us to handle, manipulate, and analyze structured data easily, right? So they provide high-level data structures, such as data frames, which act like Excel tables, but with coding power. Why are they important? Why is this library so important? Now, this library allows data cleaning. It means we can actually use it to clean our data, transform, and extract with precision and scalability. Now, this is essential for working with large data sets, such as the type of data set we use in the energy data set. Now, let's look at the nitty-gritty in loading data sets. Now, before we proceed, I would like you to understand what the concept of data set is. So what is a data set? All right, so a data set could either be structured or unstructured, but in our case, using the power consumption logs, which is a structured data, right? So typically, this data includes fields like voltage, power, and sub-meter readings over time. So why pass date time? Now, passing the date time column converts plain strings into time-aware objects. So you're going to see us using the pass date time method to achieve this during the coding section of this lecture. And also, this enables powerful time-based analysis, such as grouping by hour, day, or month. So without passing date time, it's going to be strenuous, difficult for we to be able to group by hour, day, or month. Now let's identify key numeric features. What are numeric features? These are quantitative measurements such as active and reactive power, voltage and current intensity, energy readings from different appliances. Now, why select them? Why should we select these numerical features? Now, feature engineering starts by choosing relevant numerical attributes that contribute to prediction or classification. Excuse me. Ensuring data type compatibility. Now, let's understand the importance of these features. Why convert data types? Raw data may contain strings, representations of numbers, or mixed types. Machine learning models require consistent data types, usually floats, for numerical features in order to perform mathematical operations. Now let's look at the impact. Now this prevents runtime errors and ensures model can calculate relationships accurately. So it's very important that we convert data types into a consistent data type. Next is extracting hour of the day. Now, what does this mean? Why extract hour information? Hour usage often follows a daily pattern, which means we could have high usage in the morning and evening and lower usage at night. By extracting the hour, we can model this diurnal behavior. Example use case: a spike at 6 p.m. may indicate cooking or heating, which is very useful for predictive energy demand model. So by extracting hourly information, this can help us identify usage pattern, usage behavior, okay, during prediction. So this will help us identify at what hour of the day do we have spike, okay, in power usage. Now, extracting day of the week is very important. Let's look at the purpose of weekday features. Now, human behavior varies by weekday, e.g., we have weekdays versus weekends. Businesses and homes often show different power usage on Monday versus Sunday. So let's take a look at the applications. Now, this helps to distinguish work to week patterns from weekend relaxation routines. Now, for example, there will always be high usage of power during the weekdays like Monday to Friday for businesses, and probably we're going to have less usage for homes between Monday to Friday. And then for weekends, probably we're going to have very low usage of power for businesses, and for homes, since most of the people or families usually stay at home, so therefore we're going to have spike or surge in the use of power. So these information, these features are very important. It provides more insight into usage pattern and behaviors. Scaling and normalization. Why scale features? Machine learning algorithms are sensitive to range of input data. For example, kilowatts, which is power, and volt in voltage are on very different scales. We can see that kilowatt is very large compared to volt. All right, so we have two common techniques we can apply in terms of scaling features. We have standardization, so which centers the data in terms of mean is equals to 0 and standard deviation is equals to 1. We also have another method called the min-max normalization, which is the minimum maximum normalization, which scales value between 0 and 1. So it gives a range. Now, when to use? Standard scaler is good for Gaussian distributed data, while the min-max scaler is better for data that must remain bounded. Okay, applying feature scaling. What does feature scaling do? Now, feature scaling transforms raw numeric values into a consistent scale across all features. It prevents large magnitude features like voltage from dominating smaller ones like submetering. So if this happens during training, then the model will become biased, focusing on the features with large magnitude. So this is why it is important that we do feature scaling. So why two versions? Some models perform better with standardized features, others normalize data. So what would be the best option? The best option would be for you to experiment with both and then choose which is better. So this is the best practice. Deriving new features such as the apparent power. So sometimes we will need to derive a new feature which is known as feature engineering in order for we to provide more insight into the data and make informed decision. And then understand users' behavior, which can help us decide on what model is best in terms of training. Now, if we look at apparent power, in this case, it's the combination of active and reactive power. In electrical systems, active power does the real work, e.g., heating, and then the reactive power sustains the electric and magnetic fields. So therefore, the apparent power gives a holistic view of total energy capacity used. So in this case, we have to derive a new feature which combines the active power feature and also the reactive power feature in order for we to have a rich and robust feature that combines both. Now, the usefulness is that this captures complex interaction in electrical usage and also adds predictive power to energy forecasting model. So this will enable our model performs very well and also improves the performance and accuracy of the predictive model. Now, the formula for the apparent power is presented as the square root of the summation of the active power square plus the reactive power square. Now, the next thing we need to do after engineering our features and deriving new features, we need to save the engineered features. So this is what feature engineering is all about. It's actually deriving new set of features, okay, which combines two other features or extract important details from other features. So why save the final data set? After transforming raw data, you create a new version that is rich in features and model ready. So therefore, saving this version avoids redoing the same transformation all over again, and it also makes it easy, okay, for you to share and deploy. Now, for you to do this, you can actually save using different file formats. It could be the CSV, it could be the .txt, but then it's commonly saved using the CSV, okay, for portability across tools and platform. All right, so at this point, I would like to say thank you, and I hope to see you in class during our day 4 lectures. However, we're going to be having the coding section for this lecture, and I hope to see you. Thank you.